Okay, this is 5.3.1, right? So section 5.3, we're going to get into some really interesting stuff. We're just going to focus on similar triangles. And we're going to start with a postulate. It's called the angle-angle similarity postulate for triangles, right? This doesn't apply to anything but triangles. It does not apply to quadrilaterals or anything with more than three sides. And you'll see the reason for this in a second. So this is a postulate, and you'll remember that when we use postulates in the last course, that is when we are simply going to agree that this is true without proof. There will be other proofs that we will create and theorems we'll create, but we need a starting point, and that starting point is the angle-angle similarity postulate. So what I've done is create some triangles that have, let's see if I can do this, yes. So triangle ABC has two angles, 32 and 67, 32 degrees and 67. First of all, you can see that I can make this bigger and smaller, right? And that they generally have the same shape. What I also did was draw another set of orange triangles over here, right? And these have a 32 and a 67, and maybe this drives the point home even more, right? That as you look at these two figures, these two triangles, it should be clear to you that what's happening here with this proportion, right? Let's say that's twice its size. Well, that's preserved here and here, right? And in this one over here and this one over here. It's pretty clear to me. Hopefully it's clear to you. And what's happening is, and we don't know this, but let's see. Right? We've got 32 degrees, we've got 67 degrees, 32 over here, 67. Somewhere in your past, you learned something about the angles of a triangle. And we need to forget that because we haven't proven that yet. But you'll remember some. I'm not even going to say it because we haven't proven it yet. But it turns out that the angles of a triangle do add up to the same number each time. But in this case, just for our purposes, angle-angle similarity, if two angles of one triangle are congruent to two angles of another, then those two triangles are similar. And let's just say explicitly that what's here on the page, and really important I think to have this skill, we have triangle ABC, and you can almost think about it with me as well, is similar to triangle. Now what matches with A? D matches with A. What matches with B? E. And what matches with C is F. This happens to be the letter configuration that we choose often, but we just need to make sure that the vertices that are congruent match up at all times, because otherwise the reader won't be able to know which sides of the triangles are in proportion, right? And of course we would be able to say once those two triangles are similar, then we know all the angles are congruent and all the sides are proportional.